Welcome to our class on probability, where we're going to look at random variables. To start with, when we're dealing with random variables, we are looking at experiments that are usually performed a trial in an experiment. So we're going to look at trial experiments, understanding the concept of random variable, and also distinguishing between a continuous and a discrete random variable. To start with, a random variable is simply a numerical quantity that is generated by a random experiment. So we know that there are discrete numbers and continuous numbers. Discrete numbers are simply numbers that you can count 1, 2, 3 without any recurring decimals. Whereas continuous numbers are numbers that have decimals, for instance, 1.2, 1.3. In the first lesson, I explained to you that you need to distinguish these two. For instance, age of a person, what kind of information or a quantitative variable that is, it is a discrete. 24 years old. Weight is a continuous quantitative variable because it has integers or decimals in there. So in this lesson, we're going to denote the random variables by capital letters like X. And so we'll look at experiments to do with a die, to do with cards, as well as experiments to do with actual random numbers. So a random variable is called discrete if it has a finite or a countable number of possible outcomes, whereas a random variable will be called continuous if the values contain interval numbers or decimals. So a probability distribution of a discrete random variable X in this case has a list of numbers that we can count in a trial. And the sum of the probability in the discrete random variable should range between 1 and 0, meaning the summation of the expected probabilities in the discrete random variable must always be equal to 1. So we're going to look at a fair coin. Now, a fair coin, if it's tossed twice and has an equal chance of having a head or a tail. So we're going to construct what we call a probability distribution of X, and also we find the probability of having at least one head. To start with, if you're going to toss a coin twice, we're going to have the following sample space. When we toss for the first time, we said that we're going to get a head. When we toss for the second time, we're going to have a head again. That is the trial number 1. If we toss, we can get a head. Then secondly, we get a tail. That's trial number 2. We can toss, we get a tail now. Then a head for the second time. That is trial number 3. We can toss for the first time, we get a tail. And we got to toss and we got a tail for the second time. So these are the only possible outcomes that we can have if we tossed a coin twice. All right, so we get head, head. So if you're going to use a tree diagram to illustrate this illustration, we have 2 trials, trial 1 and trial 2. So there are 2 possible outcomes, a head and a tail. A head and a tail. A head and a tail. So the outcomes of the sample space here will be a head and head. The second outcome could be what? A head and tail. Third outcome would be what? A tail, then head. The fourth outcome would be what? A tail and tail. These are the only possible outcomes. So far, are we together? Now, the question wants us to find out what, suppose X is a number of heads. Construct a distribution, probability distribution, so heads. So we're only concentrating in what? Heads. Let X be what? Heads. So how many heads do we have here? The total number of outcomes here are 4. How many heads do we have here? 2 out of the 4 outcomes. How many heads do we have here? 1 out of the 4 outcomes. How many heads do we have here? 1 out of the 4 outcomes. How many heads do we have here? 0 out of the total number of heads. Okay. So there's only numbers hovering 0, 1, and 2. So we can let the number of variables here that we're looking at be 0, 1, and 2. All right. So far together, because we want to come up with a probability distribution. So what's the probability of having 0 heads? Which is, what's the probability of having no head at all? So here, this is one outcome. It's one outcome where there are no heads here. Here, there's one outcome and another one outcome. And here, so let me repeat. I let X be the number of heads here. So where do we have 0 heads? We only have here, we have 0 heads. So here it's 1 out of 4 outcomes. So which is 0.25. Where do we have 1 head? Here and here. So this is 2 out of what? 4 outcomes. So this is what is giving us 0.5. And where do we have 2 heads? There's only one instance where we have heads, so 1 over 4. So this instance, we're going to have 0.25. The total must add up to 1. Any questions so far? So you're able to draw this distribution, if you like, as follows. 0, 1, 2, 3. And the probabilities were 0.25, 0.5, 0.75. If you want, you can end at 1. So the probability of having 0.25 here, so 0.25. Okay. Probability of having a 0 head. So we have 0, 1, 2. So having a 0 head is 0.25 or a quarter here. Of having 1 head is 50% here. Of having 2 heads, it's 25% here. So this is how we can plot this as well. So this is how we go about this. So if we're going to draw this, it will come out something like this. So 0, that's 25%, 1, 50%, 2, 25%. So this is how we sketch that. All right. The other question is, what is the probability that you're going to have at least 1 head? At least 1 means 1 and above. So at least 1, we're going to have 1 and 2. So probability of at least 1, in this context, we're going to say probability X is greater or equal to 1. So this is probability of 1, that's probability of 2. So what was the probability of 1? 0.5. What was the probability of 2? 0.25. So you add them up. 0.5 that's 0.25. So this is 0.75. If they ask you to find the probability of at most 1, it means 1 and below. 1 and below. Any questions? Right, let's go to look at another example. So suppose a fair die is rolled. Let X be the sum of dots of top faces. Construct a probability distribution of X. Now a die, you know, has 6 sides, all right? So in this die, we could have the following possible outcomes. For instance, I can look at maybe die 1 and die 2. So die 1 obviously has numbers 1, 2, 3, 4, 5, and 6. Die 2 also has numbers 1, 2, 3, 4, 5, and what? And 6. So it's possible to get 1, 1, 1, 2. So on the second die it's a 1, on the second die it's 2. Then here 1, 3, 1, 4, 1, 5, and finally 1, 6. Then we go to the second die, it will be 2, 1, then 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And here it will be 3, 1, 3, 2, 3, 3, 3, 4, and 3, 5, and 3, 6. And on the fourth, we have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. And here we have 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And finally, we have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. All right. Now the following questions that will come will be, number 1, what is the probability of having a 4? So you need to be aware of the right diagonals. So what's the probability that we're going to get a 4? So you go to this first row, look at the number we're getting, which is a 4. So here we have a 4. So get the diagonals. So here 4, and this is 4, and this is 4. These are the only 4s you're going to get. The total outcomes here are 36. Probability, we're going to get X is equal to 4, will be what? 3 out of 36. How about probability that the sum will be what? 9. We'll go where there is 9. 9 is starting from here. 9, 9, 9, 9. Only happens on right diagonal. So we have 1, 2, 3, 4. So 4 out of what? 36. Who wants to try? What's the probability that we're going to get a 3? Sum of 3. Which diagonals are we going to consider? 3.
1,2.
1, 2, and 2, 1. So this will be 2 outcomes out of what? 36. Then we also have a 10. We're going to get 10. There's this, and this are 3 out of 36. We're going to get 11. They're 2 out of 36. We're going to 12. 12 is the highest number. We're going to get 1 out of 36. So if you're going to come up with a frequency distribution diagram, we're going to have 1 out of 36. The highest number is 12. We can't have a 1 there. There's no 0. So what we're doing here for 2, this is just 1 out of 36. For 3, these are giving it the 12. For 4, these are 3. For 5, these are 4. For 6, these are 5. Okay. For 7, these are 1, 2, 3, 4, 5, 6. For 8, these are 5. For 9, 1, 2, 3, 4. For 10, 1, 2, 3. For 11, 1, 2, for 12, 1. Are you getting? Are you getting the logic?
No.
The sums, if you could see here, the probability let X be the sum for 2. Which one is giving you 2? 1 plus 1 is 2. So there's only 1 out of these. All of them are 36. So only 1 out of 36 will give you a sum of 2. 3, how many are they? 2 plus 1. 1 plus 2 and 2 plus 1. These are only 2 outcomes. Here there are 2. So 2 out of what? 36. How many are giving us a sum of what? So this is sum 2. This is sum what? 3. This is sum 4. This is sum of what? 5. 4 plus 1, 3. All these will give you a sum of 5. These ones here, sum of what? 6. These ones are giving you sum of 7. Sum of what? 7. These ones are giving you sum of 8. These ones are giving you sum of 9. These ones are giving you sum of 10. These are giving you sum of 11. And this is 12. So how many are giving you sum of 3? 1, 2. So that's where the 2 is coming from. 2 out of 36. Which one is giving you a sum of 4? A 1. Sum of 4, 1, 2, 3. That's where the 3 is coming. Which one is giving you sum of 5? Sum of 5 is here. So 4 plus 1, 3 times 2. All these are giving you sum of. So they're 1, 2, 3, 4. You get it now?
Yes.
Right. Now, in this event, if they ask you what's the probability of getting a sum greater or equal to 9. So sum which is greater or equal to 9 is starting from where? Here, going this side. Greater or equal to 9, so we need to add this answer plus this answer plus this answer plus that answer. So 4 over 36 plus 3 over 36 plus 2 over 36 plus 1 over 36, all right? So what do we get? We get our final answer. So that is how we go about it. How about if they say, find the probability that the sum will be less than 4. Which sums are less than 4? 3 and what? 2. So we add them. 1 over 36 plus 2 over 36. So we're going to get 3 over 36. Suppose they said less or equal to 4. We start with 4 itself, 3 and 2. Right together?
Yes.
Very important. So the other question was, what is the probability that X will be an even number? So even number starts from sum of what? 2. Which other one is even number? Sum of 4. Which one? 6, 8, 10, and what? 12. Are together.
Yes.
So even number, we have 2, 4, 6, 8, 10, 12 when you add them. 1 plus 3 plus 5 plus 5 plus 3 plus 1, we get 18 over 36 in decimal, which is 0.5. All right. So suppose you are being asked to find probability that the sum is a prime number. Which ones would you pick?
Three, 5, 7, 9, and 11.
Good. 3, 5, 7, and 11. These are prime numbers. 9 is not a prime number, just an odd number.
Mm.
Okay. So this is to do with the cards. I hope this makes more sense now. So now if you're asked to now draw a probability distribution, it's the same thing. You can convert this to decimals if you want. So that we have 2 against 2 against 0 point what? 0 or 1 over 36 in short. Then 3 against 2 over 36. 3 over 36. 4 against what? 3 over 36. 4 against 3 over 36. So you go on and on according to the way the function would be. Any questions? So we can go to another question on how to calculate the mean, the standard deviation, and the variance. So if we're dealing with the random variables, to start with, I said the values must be what? Be equated to 1. 0 0.5, for instance, 0 0.3, and 0 0.2. Question number 1, are they equating to 1? You add them up. Are they equating to 1?
Yes.
Yes, equating to 1. And then we get the mean. You need to multiply this by that. What are we getting? 1 times 0 0.5, 0 0.5. 2 times 0 0.3, 0 0.6. 3 times 0 0.2, 0 0.6. And when you add them up, what do we get? 1.7. That is what we call the mean, the mu. Then we now square our values of x. The same probabilities are what we're going to use. 0 0.5. We use a different color. 0 0.5, 0 0.3, 0 0.2. But square 1 squared is 1, 2 squared 4, and 9. All right. So we now square x squared times the probability of x. So 1 times 0 0.5 is 0 0.5. 4 times 0 0.3 is 1.2. 9 times 0 0.2 is 1.8. So what do we get? When we add up, so here we're going to get 3.5. So 3.5 is the sum of x squared px. So to find our variance, it is simply the sum of x squared px times minus the mean squared. So here it will be 3.5 minus 1.7 squared. 3.5 minus 1.7 squared. What do we get? 0.61. Can somebody take us back? How did we find the mean? Given the random variables x and the probability of x. Any questions? How did we find the mean? 1.7? Yes, Nana? How did you find the 1.7?
We multiplied x, x, x.
We multiply p
We,
probability of x times the random variable x,
yes.
then we sum up.
Or
So this times that, this times that, then we sum up. That is how we find the mean, correct? And how do we find our variance?
we multiplied x squared
So we squared
times the
x first of
probability
all.
of x
Then we brought
times
the
the
probability of
probability
x,
of
say multiplied 1 times that, 4 times that, 9 times the probability. The total is not the variance, but when you subtract 3.5 minus the mean squared, that is how we found 0.61. So meaning the standard deviation is simply when we square root that the variance. So square root of 0.61 is called our standard deviation. So square root of answer is 0.76. 0.78. So that is how this is supposed to be done. All right. So how do we then calculate the probability to find our expected value? So here are given values of x and the probabilities of x in here. So we simply multiply this by that, plus this by that, plus this by that, by this by that. The total is called our mean. As simple as that. Okay, so how do we find our variance? We square each of these x's, and the answer will subtract the mean. So to find our variance, we need to square each of these ones. So my table is very simplified. Remember, you can simply find the values of x, -2, 1, 2, 3.5. And square the values of x if you want. 4, 1, 4. The square of 3.5, when you square it, to give you 12.25. And the probabilities, we have 0.21, 0.34, 0.24, 0.21. So to find the mean, x and xpx, so we multiply these two. So -2 times the probability of x. So when you multiply, what is 0.21 times -2, we get -0.42. 1 times that, we get 0.34. 2 times that, we get 0.48. And this by that, ultimately the total will give us 1.135. Are you following?
Yes.
Anyone behind so far? I need you to be at the same page. Pasinati, are you following?
I'm following.
All right, so for the variance, you multiply this square times that, this times that, this times that. The answer you get, you subtract our mean. Then to square root it, it will give us our standard deviation. So this is basically what you're supposed to do here. Well, look at this other example here. We're told that a service organization organizes a raffle. This raffle, 1,000 tickets have been sold for $1 each. And each has an equal chance of winning the first prize, which is $100, $300, second prize, $200, the third prize is $100. So let X denote the net gain. So the net gain from the 300, you subtract a 1 here. So 300 minus 1, because you're removing how much you spent. It's 299. What's the probability? It is 1 in every 1,000. The net gain of getting a 200 price, you will subtract a 1, your amount you got, this is what? 199. The chances is 1 in 1,000. Right? Then finally, the net gain of the third price, subtract a $1 which you put in, remains 99. The chances of getting it was what? 1 out of 1,000. And finally, if you're not going to invest anything, and you subtract 1, you're still losing out. So we apply that, the principle of losing a ticket. So here -1 minus the opposite. Okay, which is 997 over 1,000. So this is what we call the probability distribution. That's the probability distribution. Right, so the variance, I've already explained how to go about it. You can use two methods, what I just explained and what is yet to be explained down here. So basically, this is how we do the random variables. Unless there are any questions.